Hello, everybody. My name is Gabriel Illés, and I'm from Grow to Fit. And I would like to talk about about how to use OpenTelemetry Collector in observability for distributed systems and edge computing. So, as I mentioned, I'm working as a senior DevOps engineer for the Grow to Fit. I'm in the DevOps more than 3 years. Before that, I was working as a solution designer for big data solutions. And I'm now more than 1 year, I'm working on observability in Kubernetes. So, what is observability? As most of you know that observability is not just about monitoring, so collecting metrics and visualizing that. So basically, it has other 2 pillars, so collecting the logs and traces from applications. And in most of systems, those 3 pillars are handled separately. So from my experience, always the first thing that people implement is monitoring, and other 2 things as collecting the logs maybe could be the second one, but it's very few of projects using the collecting tracing from applications about the behaving the applications. So I would like to talk about all the 3 aspects of the observability, so and how it is implemented in OpenTelemetry. So today there was one presentation about also where the OpenTelemetry was described what it is. So it's basically a vendor and tool agnostic framework which can generate and manage telemetry data. But as also was mentioned from my fellow speaker, that it is not a backend for observability, so it has no storage. What you need, an additional storage where you can send data from using the OpenTelemetry. It basically could be Prometheus or Thanos or other backend used for traces or logs. So the main component of the OpenTelemetry is the collector itself, and it offers also a vendor agnostic, and it's a single binary what you can download and use from their GitHub repository. And as you see, the architecture of the collector, so basically it has 4 basic components as receivers, exporters, processors, and extensions. And from those, the receivers and the exporters are mandatory to use for the pipeline. So basically those 4 components forming a pipeline, you can see the orange or the green lines which indicates a pipeline. So each pipeline has own receiver. Then you can use some processors for processing the telemetry data, enriching or cleaning up, or just use some filtering, and then some extensions which provides additional features for your telemetry data, and then the exporters, which basically is sending out the data into the backend based on the type of the telemetry data, its metrics, logs, or traces. So as you can see, there are the links for the 2 GitHub repositories. The first one is the official OpenTelemetry Collector GitHub repository. It contains basic receivers, exporters, and components for the collectors. But there is a second one, which is called OpenTelemetry Collector Contrib. And it's an open source project and a lot of contributors developing additional receivers, exporters, and other components. So it's provides more features and lot of more components for the usage. And also there is a third one, which is called a builder. So even you can build your own OpenTelemetry collector, and you can choose which components you would like to have in that image, and just use for your own usage. And the collector itself can be deployed in 2 modes. So, and that's basically what I would like to introduce you. So the first mode is the agent mode, when this OpenTelemetry collector is deployed basically directly or the nearest possible to your application running on the same host or in the same environment. And in that mode, it is deployed or as a standalone process, or you can deploy it in a containerized environment. And basically your application is sending data towards to the collector, or your collector scraping metrics from the applications, and then sending out the data directly to the backend, or to other type of the collector, which is the gateway mode, which I will show later on. So basically, the agent mode is, as I mentioned, is running directly with the application, so you can process the data locally and filter what data would you like to send out from the application toward the processing. So, and the second mode, as I mentioned, is a gateway mode, where the collector is deployed in a remote environment or in a centralized environment. For example, in a Kubernetes cluster, you deploy the collector in a gateway mode, and this gateway mode, the agent or collector is getting data from the other collectors from remote locations, and then you can do, so in the gateway mode, the collectors can get data from multiple agents, and provides a centralized way to further processing the telemetry data. So you can aggregate them, use some of the processors providing by the community or other processors to basically process your data, and then sending out to the backend for storing the data. And the next thing what I would like to talk about is the operator itself. So the OpenTelemetry also provides operator for this collector, not just collector, but using in the Kubernetes. And this operator is managing 3 types of CRDs. The first one is the collector itself, which could be deployed in different modes. As you can see, as a sidecar in any pod, you just use some annotations in the pod, and the operator, when will see that annotation, it will inject the OpenTelemetry collector as a sidecar in that pod. So basically, it also could be considered as an agent and collecting telemetry data. And the other 3 types of deployment are basically the Kubernetes most known types as deployment, daemon set, and stateful set. Also, the daemon set is very useful if you would like to deploy the collector on each node of your Kubernetes cluster and collect, for example, metrics from the node itself, as for example, Prometheus node exporter is doing. Then there is a second custom resource definition, so-called auto instrumentations, which basically also, if you define it, so the OpenTelemetry operator will inject all the instrumentation tools into the pod where you would like to use it to instrument your application, and it's providing different type as .NET, Java, Python, or Go, or something like that. And the third one is the latest one. It's a very interesting feature, the target allocator, because it could work with the Prometheus operator custom resources as a pod monitor, service monitor. So basically using those custom resources to get metrics from services or pod. So in that way, OpenTelemetry could replace your Prometheus instances. So you're just using the CRDs without installing Prometheus services, and the OpenTelemetry Collector could take those beside the other features which you configure in the collector. And also this target allocator doing load balancing, so it will divide evenly the load between the collector instances if you have multiple, because the operator also allows you to auto-scale the collectors based on horizontal pod autoscaler. So you can define the auto-scaling for the collectors that it will auto-scale based on memory or CPU usage, and the operator will take care of the auto-scaling of the collectors in a Kubernetes. Oh, and basically this is a high-level design how you can deploy or use the OpenTelemetry collector to collect data from distributed systems. So as you can see that there is a installed collector in agent modes in some edge locations or even in a cloud environments. For example, you have your application running on a virtual machine, standalone, and you can deploy the collector beside that application and collect the data, and then forward the data to the collectors installed in a Kubernetes cluster managed by the operator acting as a gateway. And then the gateway collectors will send out the data to the centralized storage or tracing platform or where you can send and use it. So basically, in the end, it could be any other remote location and even different cloud provider. So basically, that's why the OpenTelemetry vendor and tool agnosticity came in handy, so that you use the same code and deploy it to any environment, and it will behave the same in all these environments. So divide or bring more detail this design. So let's see that how, for example, in the agent mode, the OpenTelemetry collector is configured. So basically, there is two pipelines. As you see that one pipeline, the higher one is for traces. That application is coded to send out traces, pushing traces into the OpenTelemetry Collector, which using the receiver receive these traces, and then there are some processors configured. Basically, it's recommended to use the memory limiter and the batch processor, but you also can use a so-called attributes processor, which provides you that with feature add additional labels or into the metrics or additional information into the traces about your environment and so on. And also for the second pipeline for metrics, which is pooling as a Prometheus receiver, pulling out metrics from replication. And also it could work with the exporters which was developed or are available for any Prometheus. So basically, if you have some node exporter on the node, you can configure your hotel collector with Prometheus receiver just to use that endpoint and pulling out metrics from your application. And also in the pipeline, you can do some processing of the data. And as you can see that the two pipelines have one common, using the one common receiver, which is called the OTLP receiver, which is the OpenTelemetry protocol, and it provides HTTP and gRPC type of sending out the data, and it is very useful that using this OTLP exporter to send out the data from the agent towards to the gateway, because then you also see that in a gateway you're using the same OTLP, but as not as exporter but as a receiver. So with communication between the hotel collectors using the same protocol and understanding each type of the data, so you do not need any further modification. And then in the hotel collector itself, then you can define again a different pipeline for your tracing and for the metrics, and then defining different exporters to send out traces to the tracing platform, and metrics sending out to some TSDB platform as Thanos or Mimir or anything else which can collect your metrics data. So basically this is about the design, how the OpenTelemetry Collector could be useful collecting data, observability and telemetry data from distributed systems, which has multiple components on remote locations. And basically then you have just one centralized source for your telemetry data, and you can use those central source for visualization, for example, Grafana, doing dashboards on metrics, on top of metrics from all of your environments. And I would like to also talk about the performance of the OpenTelemetry Collector, because in such a setup, when you have these multiple environments, you can have then heavy load on these collectors, and you can get a lot of data, metrics, and so on. So basically, the operator, as I mentioned, the operator can scale the collectors, but there are some recommendations that where to scale, how to scale, and what to scale. So basically, for example, there are very, very useful metrics, and the OpenTelemetry Collector could monitor itself. So you can configure that when you deploy the collector, it's also providing the /metrics endpoint with useful metrics, which then you can use for checking the load or the behavior of your OpenTelemetry collector. For example, what I mentioned, this memory limiter processor, if you add this into the pipeline, you can set up that the collector, how much memory could use from your pod. So basically, and then if this limiter reaching this limit, for example, 80% of your memory could be used by the collector, then it starts to dropping the data. And that's, there are some useful metrics which you can use for monitoring the load on or behavior of your collector. And based on that, just scale the collector vertically or add more instances. And also there is a so-called capacity, queue capacity. So it's also configurable. The default value is 1000 data. And if your memory or the collector has a lot of data, so you can see that there is defined capacity, and the size of your queue could indicate that there is something happening in a collector. So, these metrics are useful, but not in every case. The collector itself has problem when the data started to be queued in memory of the collector, because it's also on your backend. For example, if you have a Thanos backend and Thanos have this receiver component, and when the Thanos receiver is not able to write out the data in that amount or with that speed, so it will not give a backward acknowledge to the collector that, okay, I have written your data. So it also could cause that your queue in the collector start to fill up. So it could be a good indicator that something is happening. But for example, if you start to increase the queue and you see that even the queue is increased, but the size is increasing also with that in the same proportion. So it could be the indicator that not your collector, but your backend is not capable to handle that much of data. And also there is another metric useful when you see that can indicate that the sending out was failing. So, and these metrics, you can see that at the end that it's mentioning that the spans is for tracing, but those metrics are available for all three types of the data. So the metrics will be called at the end not failed spans, but will be failed metrics and failed logs. So if you have all three pipelines defined in a collector, so those metrics will be available for you for the monitoring. And about the security of the OpenTelemetry Collector, it provides basic authentication, so you can configure the OpenTelemetry Collector using TLS certificates, also basic HTTP authentication with username and password, and also it provides the OADC authentication, which you can configure and connect, for example, to OpenID or Keycloak or something like that, which is used for OAuth authentication. And from the security perspective, it's also the good point to have the least privileges, and also what I showed before, that existing a builder, so you can build your own OpenTelemetry Collector image just containing those components what is needed for your load or configuration, because it's also could increase the security of the collector. And the third aspect that don't forget update the collectors, because could contain old version, could contain some vulnerabilities, and it also could lead to security breach in your environment. So basically that's all. Thank you. Question, can the metrics sent from one agent to multiple different destinations at the same time? Yes. So you can define, as I mentioned, the pipeline, and you can define for the same data multiple exporters which will send out the data. As in, for example, in the Prometheus, you can define multiple remote writes destinations. Also, hotel collector have this Prometheus remote write exporter. So you can configure it in the same way as your Prometheus, sending out the data to the multiple destinations. When I start to using hotel, will I still need Prometheus? No. When my Prometheus is already just only scraping metrics and remote write it to Thanos, it's already just, so basically in that way you can replace your Prometheus instances with hotel. As I mentioned, it provides Prometheus receiver and Prometheus exporter. So basically you can take your Prometheus job configurations, put into the hotel collector, into the Prometheus receiver configuration, so it will scrape the same endpoints, same metrics what your Prometheus is doing, and then the Prometheus remote write exporter you can configure to endpoint to the Thanos. So basically it will replace your Prometheus instances, and you do not need to change nothing on your application and so on. So just take the same configuration from the Prometheus and put into the hotel collector. Can the application be blocked while trying to push traces to the agent? Trying to push traces to the agent. I don't know, because on a project when I'm currently working, we using some traces, but not at that level or that load. So I know that there are applications which are already sending out traces, and our observability platform is handling so far the data, so we cannot get any compliance from the applications team that our hotel endpoints are not handling or struggling with handling the traces. So far it seems good. Any recommended open source APM solution that supports or uses hotel collector? I'm not sure what is it, you mean the APM? I don't know. Sorry. So that was the last one. Thank you.